Hello everyone, we're going to do two-column proof, and we're going to try and prove that x is equal to 2 given that 3x plus 5 equals 11. Notice this is algebra. And statements column, we have a statements column and a reasons column when we do two-column proofs, and it's a very formal proof. In the statements column, we're going to write statements and conclusions. And every time I write a statement, or every time I write a conclusion in this column, I need to provide evidence that say why my statements and that say why my conclusions are valid. So every time I write something here, on the reasons column, I have to write why this statement that I made is valid. So that's what we're going to do in a two-column proof. Remember, anything I write here, I have to validate it with a proper reason. Now, what are valid reasons? Valid reasons for this column are definitions, properties of equality, congruence, theorems, postulates. All of those are valid reasons in the reasons column. So every little thing I do in the statements column, I need to validate it over here in the reasons column, okay? So let's look at this. Before we start proving, let's look at what they're asking me to do. They're telling you 3x plus 5 is equal to 11. That's the given statement. Look at the given statement as if it were a hypothesis. And if you already know about if-then statements, you can think about the given statement as your hypothesis. So we're saying if 3x plus 5 is equal to 11, then the conclusion is that x is equal to 2. And I need to prove that. Now, in between this hypothesis and the conclusion, it's like a puzzle. We need to get from this point to this point, and in between we have many steps. And what are those steps? Those are the steps I'm going to write here in my statements column, and which I'll validate in my reasons column. Okay, so before we do that, let's make a plan. I'm going to write a plan of how I intend to prove that x is equal to 2. So let's just go here to the side and say, okay, this is an equation. It's a two-step equation. So how would I solve this using algebra? This is what I would do. I would write my equation. The first thing I would do is I would subtract 5 from each side. That's the first thing I would do. And then I'll end up with 3x equals 6. And then to isolate x, I would divide by 3 both sides, and x would equal 2. And there, I've reached the conclusion. And there, as you can see, from the hypothesis way down to the conclusion over here, there are a series of steps that I need to make in order to get here. So let's do what we did here using algebra, and let's write it out in the two-column proof. As my first statement, usually your first statement is always the given statements. So let's write the given. 3x plus 5 is equal to 11. And remember, every time I state something here, I have to validate it with a reason. The reason is asking you, oh yeah, 3x plus 5 is equal to 11? How do you know? And you're going to say, well, it's given information. And that's the reason, given, okay? For my second statement, remember your plan. In your plan, the first thing you do to get to the proof statement was you subtracted 5 from each side. Now, we can't write minus 5 on each side here in the statements column because we're not doing algebra in the statements column. We're simply presenting statements and proving that what we're doing is valid. So I want to talk to you about the subtraction property of equality. The subtraction property of equality says that if you subtract the same number on both sides of an equation, you will end up with an equivalent equation. Notice what it says. If you subtract the same number. So before I subtract, I first have to state that these two numbers are the same number. I have to state that 5 is equal to 5. And that might seem a bit trivial to you, and in a lot of books, this step is skipped. You will usually see that in a proof statement, they will just go ahead for step 2, they will just go ahead and write 3x is equal to 6, and they will write subtraction property of equality. Okay? You will see this a lot, but I'm very picky with proofs, and I like to validate each one of the steps. And before I can write 3x is equal to 6, I have to state that 5 is equal to 5. Because the next property I'm going to use, which is if you subtract the same number, someone can come and say, wait a minute, how did you get to 3x equal to 6? How did you get to 3x equal to 6? And you're going to say, oh, I subtracted 5 from each side. But wait a minute, who said you can subtract 5 from each side? The subtraction property of equality says that if I subtract the same number from both sides, I will still have an equivalent equation. And then they can say, how do you know 5 is equal to 5? And then you can provide proof. You can say, oh, I know 5 is equal to 5 because there's a property that's called the reflexive property of equality that says that any number is equal to itself. It's like looking in a mirror. The reflexive property of equality says that A is equal to A, or 5 is equal to 5, and 3 is equal to 3, and you are equal to yourself. That is the reflexive property of equality. It's evidence that a number is equal to itself. So I like this property, and I like using it when we're solving equations. So now that you've stated that 5 is equal to 5, okay, and you've given a valid reason to say that that is equal to 5, I can go ahead and make my third statement, and my third statement would be this one here. 3x is equal to 6. Remember, when we're proving in a 2-column proof, we're not doing algebra steps, but stating how we get to those steps, okay? So now, notice that I have 3x equal to 6, and someone can ask you, wait a minute, why did you write 3x is equal to 6? And you're going to say, well, because I used the subtraction property of equality that says if I subtract the same number from each side of this equation, then I end up with an equivalent equation. And here's the equivalent equation I ended up with when I took this 5, which I've stated already and presented proof that 5 is equal to itself. So now this property that makes very clear that if you subtract the same number, and I've stated it is the same number, okay, I'm not cheating here, I can subtract, and this is what I got. And you've validated it with the subtraction property of equality. Okay, now my next step is step 4. If I were doing algebra, I would divide by 3 each side. Now be careful, because the division property of equality, I'm going to scroll down here just a little bit. The division property of equality says that if you divide the same number on both sides of an equation, you will end up with an equivalent equation. So again, notice it mentions that it has to be the same number. And for the division property of equality, that number cannot be 0. And since it states that it has to be the same number, again, I need to state before I divide by 3 that 3 is in fact the same number as 3. That way no one can stop me and say, wait a minute, you didn't provide any evidence about 3 being the same as 3, and the division property states that it has to be the same number. So here you're telling them, look, 3 is equal to 3 by the reflexive property of equality. Okay? So once you've stated that, you can now state, step number 5, that x is equal to 2. Because now, since 3 is equal to 3, and I can divide each side by 3, when I do get to that step where I divide, this is what I would end up with when I divide by 3 both sides. So they're going to ask, how did you get to x equal to 2? And you're going to say, well, I used the division property of equality. And there you have it. And you've reached your proof statement, which was prove that x is equal to 2. Notice we had our hypothesis, and we got all the way down to our conclusion, and in between, we had to state several statements and provide proof for each one of those steps. I hope you understood. I will make more videos on 2-column proofs. This is using algebra. The next one I'm going to do is using a segment. I will see you in the next video.